In this video, we're going to be covering experiment 15.2, and this is covered both in the hardcover book, pages 543 to 546, and your student notebook, 575 to 578. If you own a student notebook, and I'm talking about this soft cover student notebook, please take it out because you're going to be writing in it for your lab report. And if you don't have a student notebook, you can just put it on the information on another piece of paper. All right, in this section, the book provides a nice background for the experiment. We're going to be looking at the effect of temperature on the equilibrium of reactions, particularly in the light of Le Chatelier's principle. So just to review the difference between exothermic and endothermic reactions, we know in exothermic reactions, our delta H is negative and energy is considered a product. Let me just turn this way a little bit more. Okay. And then in endothermic reactions, the delta H is positive and the energy is put on the reactant side. Now just a note, even though this delta H is negative, when the energy is added excuse me, to the product side, it is still added in a positive amount. It's like an absolute value when it's added over there. But in regard to Le Chatelier's principle, we've seen some patterns, and so we can see this when temperature is raised in a system. The equilibrium will shift away from the side of the equation that contains energy. So in this particular equation, again, the energy is on the product side. If this whole system was heated up, the equilibrium would shift away from this side over to the reactant side. And if you're looking at an endothermic reaction, the energy is on the reactant side. So if that's all heated up, then the equilibrium would shift over to the product side. Now we have, conversely, if the temperature is lowered, so if we cool down the reaction, then the equilibrium will shift toward the side that contains energy. So if this is all cooled down, the equilibrium will shift this way. And if this is all cooled down, the equilibrium will shift that way. So let's take a look at the summary of the experiment that we're doing. We start off just by working with a regular ammonia. So this is the container that I used. That's the NH3. And we're combining it with the vinegar that has acetic acid in it. And this is the formula for acetic acid, the C2H4O2. And then they'll combine to form an ammonium ion and an acetic acid ion. It looks like we have a visitor. My cat is over here. Again, can't stay away from my lectures. Oh my goodness. See him? Okay. So in order to sort of visualize a change in pH for these reactions, we use the cabbage water that we've used in the past. It's we take red cabbage and boil it in water, and it releases a pigment that serves as a natural pH indicator. So typically with this pH indicator, if it's acidic, it'll look pink, and if it turns to neutral and then basic, it goes from green and into blue shades as well. So we're going to be working with two samples. So just to show you here, this is the initial part of the reaction. I've put two reagents in this. I put the cabbage indicator, and then I put was 20 drops, and then 15 drops of vinegar, which would have the acetic acid, and that's why it's so very pink. Then, after that, I have added, actually to 2 separate tubes, but same concept, added ammonia, and titrated it until I changed each sample to the very drop where it turned into a green color, and then I incubated it in a cold ice bath for over a minute. Actually, it's been about 3 or 4 minutes, but we're looking to see beyond that point that if the test tube stays cooled, right, the equilibrium reaction should shift toward the products, and then the book predicts that the indicator would turn or remain green. And then if you heat up one of the samples, then it more or less is adding a product to this side of the equation, and the equilibrium would shift away from that toward the reactants and turn a blue shade. So that's what their prediction is. So just to give you a heads up on your lab report, okay, you're going to either write this information in your student notebook or again on a separate piece of paper. You'll hand it in online by May 1st. It's 30 points. So we're going to take a moment in just a couple of minutes to write a hypothesis. You can use page 577. In your hypothesis, you want to state whether you think there will be a shift in equilibrium due to the difference in the temperature, and whether or not you'll be able to visualize it. And then for your data, there's 2 important steps. You want to compare the color in the test tubes when they've both just been in the cold area, and again I'll point out when you're going to do that. And you have to also compare them after one was heated, and again I'll provide a moment to do that. And then for your conclusions, you just write whether your hypothesis was correct, whether your observations were the same as the book predicted, and if they weren't, do you have any guesses as to why they were different, and then any thoughts on how you can improve the experiment. Okay, so now is the time to embark on actually writing in your notebook. You can take a moment and pause the video if you like, write a hypothesis on whether or not you think there will be a shift in equilibrium and whether you will see a color change when the test tubes one of them is going to be heated. So that's your hypothesis. And then when you're done writing that, you can resume the video and watch this experiment. So our first step is 21. You see here, that's what you're going to write in now. I'm going to show you these 2 test tubes once again, and as I mentioned before, we have in there, we put in the cabbage indicator, the vinegar, and then ammonia. Then I cool them down in an ice bath that's at about 5 degrees. And you have to write in your book whether or not you think they're the same or different colors. And if you can describe the color, that would be nice too. All right, now to proceed on with the experiment, I'm putting one of the tubes into, will be, let's see, I have them marked cold and hot. Use that one. So this one's marked hot. That goes into this heated bath here, and it's supposed to stay in there for 30 seconds. So I am keeping track on my clock, and after the 30 seconds, we'll be looking again at the 2 samples, and then you will have to fill in this next step, 24, and you're going to put in those observations are the hot and cold samples the same color, and describe each color. So we're just at about 30 seconds or so. And now all right, this on the left is the cold sample, on the right is the hot sample. So tell me if you see a difference in the colors. From my perspective, I see the left side looks greener than the blue side. And then you write that in your step 24. All right, to go back then just for a moment, we'll look at what the book predicted. The book predicted that when it stayed cooled, the indicator would remain green, which was the result more or less that we saw in this one. And that the heated sample, that we're more or less by heating it, we're adding a product, and that in this case, it would shift the equilibrium toward the reactants, and the indicator would be more of a blue color. So as far as I'm concerned, I think that it is consistent with what the book predicted, but you obviously are welcome to make your own conclusions. So I hope that helps you get started on this experiment. If you have any questions, just feel free to let me know.